I just want to take a couple minutes and talk about the sine graph and the cosecant graph and hopefully give you a few pointers for the notes that you're supposed to be working on over the weekend. So right here we see the sine graph. And now what I've just done is I've added the cosecant graph. And one of the first questions in the notes is to explain the relationship. Well, based on some other notes that we've taken in the past and talked about, we know that sine and cosecant are reciprocals. So if you think about what that means, and if you look at what is happening to the graph, that's exactly what's happening here. If you, we'll start at 1 because that's the easiest. If I take the reciprocal 1, it's 1. So that's where you can see the connection between sine and cosecant. If you look at the value right here, it's half. That's sine of 30 if you recall. And the reciprocal of 1/2 is 2. So if you go up, you'll notice that then the cosecant hits at 2. And again, as I get closer and closer and I take those reciprocals of those smaller fractions getting to 0, that's going to start getting higher and higher. So again, the values of these red lines are simply expressed as reciprocals in the blue line. Couple things you'll also notice is that, or will recall, is that the sine graph is 2 pi. And if you notice and look at this cosecant graph, we have this upward looking almost parabola, but it's not quite a parabola. I just want to clarify this. And then this one opening downwards. And then all of a sudden, once we get to 2 pi, it starts doing the same thing. Up and then down. And if we keep going, up, down. So even though these graphs, these cosecant graphs aren't continuous, they are periodic. And they're periodic every 2 pi. So starting at 0, we have this upward, then at pi it comes downward, and then at 2 pi again it starts repeating that pattern. One of the questions in the notes talks about the range. And if you recall what the range is, range are basically your y values. So if we look at the just the blue line, which is the cosecant graph, you'll notice that, and I'll zoom out quite a bit, the y's actually don't have a starting value. They're infinite going up. And if we look down, same thing, they're infinite going down. So the domain, I'm sorry, not the domain, the range is going to be from negative infinity to -1. And then if you think about what happens right here at -1, oops, let's see if I can get the screen to stay. At -1, it stops and there's this gap in between. And then it doesn't start again until 1. So then that would be a union at 1 going to infinity. The other question is a little bit trickier to write down, and that it asks what the domain is. And let's go back to sine. And sine, you can notice it has this continuous, flow going up and down, but it covers every single x value going left to right. So for the sine domain, it's actually all real numbers. But if we take a look at cosecant, you'll notice that it does go forever to the left and it does go forever to the right. But unfortunately, we can't just say all real numbers because what we notice right here is that the graph actually never touches. So if we see how it's getting closer and closer, but then if we zoom in, it really never touched, and we go a little bit further to see if it does. But if I keep going and it starts appearing like, okay, it's going to do it now, and I look, it actually didn't. And if you recall what that it's called an asymptote. And remember, it's where the graph keeps approaching the line but never actually gets there, it touches there. And so it never exists. And if you notice where it never exists, it doesn't exist at 1, at pi, at 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. And hopefully you start seeing a pattern. So this is how you would describe those things. You would write an interval notation for the range. You would say from negative infinity to -1, and then the union 1 to infinity with brackets on the 1 because it 1 and negative 1 because they are inclusive. And then for the domain, you would say x such that x is all real numbers. It should have a double line for the r, except at pi n, where n is an integer. And we say pi n because it's every multiple of pi, as you can see. The next question asks, what is cosecant pi? Cosecant pi is right here. And if you notice, and this is kind of what we were just talking about, if I try to find where the graph hits at pi, this is that line right there, and I keep going up and up and up, it actually never touches. So the value at cosecant pi is undefined. And I kind of worded it kind of weird on your worksheet, and what I'm looking for is because there exists an asymptote. When it says, what is this called? It's because there's an asymptote that occurs there. The next questions ask about if we make it half sine of x, and then if we make it half cosecant of x. And we've seen this actually before, and what you'll notice is that in this case, the amplitude only goes to 0.5 and only goes down to negative 0.5. The period stays the same, but the amplitude changes. So then if we look at what happens at cosecant, you'll notice that instead of that starting point being at 1 up here, it was cut down to half. So these points in here get closer, so those starting points. The next question asks about sine 2x. And again, this is something we've talked about previously. The period changes to 0 over pi. You can see that it got compressed. And it asks what's going to happen here. Well, the point of this and seeing these is the exact same way that the numbers affect the sine and the cosine graph. They're going to affect the cosecant and the secant. So if we do put in a 2 right here, what you will notice is the period changes. They get a little bit skinnier, and instead of going from 0 to pi for this, upward looking part, it only goes from 0 to pi and a half. And then the lower part then gets cut as well, and it's a full period with an upward shape graph and a lower shape graph only going to pi. So again, I'm trying to re-emphasize the points of when you have a number in front of the x after the sign, you will have a period change. And the last two are just talking about phase shifts and vertical shifts. If we subtract pi over 2 right here, we want to think about what's going to happen. Based on our other information, we saw that it should move to the right. And we're hoping by pi over 2 units. So if we take a look, it's exactly what happened. That midpoint of that upper got shifted from pi over 2 to pi. You can see how this one was negative pi over 2, and now it's at 0. And finally, the last one asks about a vertical shift. So if we take a look last time, the red represents the normal cosecant graph, and the blue is adding a 3 vertical shift. So right here, you see how this point went up 1, 2, 3 to the blue. This point right here went up 1, 2, 3 to the blue. And basically, the other questions are wanting to think about the relationship between the two functions, that they're reciprocals, where the asymptotes are, and to show you that really those patterns carry over into these as well. Hopefully this helped a little bit.